everyone. Today we have a short lesson because you've already done it before, but in a different context. So today we're going to do section 5, part 2 about Gibbs free energy. So remember, we defined standard enthalpies of formation, which is delta H of F, as the enthalpy change when a substance is formed from its elements under defined standard conditions. So we can define standard free energies of formation, delta G, in a similar way. When I say define standard conditions, that means 1 atm, 1 molar concentration, and 298 Kelvin for your temperature. And just like standard states of formation, free energy of elements in their standard state is 0. So elements in their standard states are 0. So these are things like Cl2 in a gas form, O2 in a gas form, even things like Na in a solid form. So again, we calculate this the same way that we did with delta H and delta S, but instead we're going to be using delta G or Gibbs free energy, basically numbers. Same thing, you're going to find the sum of your products minus your reactants, where N and M come from a balanced chemical equation. So N and M are the coefficients of balanced chemical equation. Remember, elements are going to be 0. These values for delta G can be found on your thermodynamic quantity help sheet. Remember to use your delta G values, not the H or S. So these are going to be the ones in the middle. Here we have a problem. It says use the values from the thermodynamic quantity help sheet on my classroom website and calculate the standard free energy change for the following reaction if it was at 298 Kelvin. So I took a little screenshot of that little table. You're going to notice that your delta G are right in the middle. They're given in kilojoules per mole for units. Remember, always take your reactants minus your product. So here for my reactants, I have 4 of them. And then I want to find PCl3 in gas form. You're going to notice it's in liquid and gas, so make sure you do the gas form, which is negative 269.6. We want to subtract it from our reactants. So reactants, here we have 6 Cl2. Chlorine is an element in its standard state, so that's 0. Plus, we only have 1 of them, so we just have to find P4 in gas form, 24.4. From there, we can go ahead and solve. When I multiply that, negative 1078.4 minus 24.4, because 6 times 0 is 0. And when you subtract that, you get negative 1102.8 kilojoules, or you could say kilojoules per mole. Either unit is acceptable for me. In terms of answering the second part of this question, is this reaction spontaneous in the forward direction? So hopefully remember, if delta G is greater than 0, it is non-spontaneous. And if delta G is less than 0, it is going to be spontaneous. So here we have a negative value, which means it's less than 0. So this reaction is, yes, spontaneous. So here I have another problem for you guys to do. You're going to have to open up that help sheet and try to see if you can solve this one on your own. Remember, it's going to be located on my classroom website. So why don't you go ahead and do that now? Okay, let's see how you got as your answer. So remember, when you do this, you have to do your products first and your reactants second, because it's products minus reactants. So if you go ahead and set this up, we have 2 waters, and then I have to find water on that sheet. Make sure you use the value for the gas and not the liquid. So 2 times negative 228.57, oops, Okay, scratch that. Let's set that up again without messing it up this time. If your value here is incorrect, you either probably used a delta H, delta S, or you used the wrong state of matter for water. We want to add that to our CO2 value, which is negative 394.4. Subtract it from our reactants. So here we have 2 oxygen, but oxygen's an element, so it's 0. And then if you look up the value for CH4, it's negative 50.8. When you go ahead and solve this, you get negative 851.54 minus negative 50.8. And when you go further, you get negative 800.74 kilojoules, or you could say kilojoules per mole. If you were going to answer the second part of this equation, now that you've seen kind of like the right answer, I want you to tell me, should this reaction be spontaneous in the forward direction? If you said yes, it is spontaneous, you are correct. The reason it is spontaneous is because here delta G is going to be smaller than 0. And that's the end of the lesson. Very short, very sweet. Let me know if you have any questions or any issues, and I hope you guys have a good day.